everyone, and welcome to your next coalesce talk, Getting Jiggy with JSON Schemas. I am Jason Gans, and I think that they invited me here to host because JSON. And I'm so thrilled to have our two presenters here today. We have Emily Hawkins and Jake, and these are two community champions. Emily, when did you start getting involved in DBT stuff?
I think like 3.5 years ago.
Like 3.5 years ago, coalesce presenter, analytics engineering course that has gotten so many people involved, and now we're talking about the next stage of evolution of data. Many of you have heard about data contracts. How do we control our data? And Emily and Jake are going to be walking us through that today. So I will let them take it away. Reminder, questions, comments, anything, just hop onto the Slack, and then they'll be on there afterwards to follow up.
All right. How do we get to it? There we go. All right, do you want to go?
Yeah. Hey everyone, I'm Jake. Emily's going to be speaking first, so I'm introing myself first. That first slide was wrong. I work at Okta now, so I guess those are all over the place. But yeah, I've been working with data systems for a while. I'm pretty lazy, so I like to automate a lot of stuff, and that's basically what we're going to talk about.
Awesome. So I'm Emily. I'm a data engineering manager at Drizzly. As Jason mentioned, I've been using DBT probably like 3.5 years now. I'm really excited to talk with Jake today about JSON schema and data contracts. So if you're in this room, you probably know that working in data is hard. We have to deal with a lot of the upstream decisions that teams are making without involving us. But we get the Slack messages about the data being wrong, the dashboard being broken, and then we have to find all the puzzle pieces to put together so our business users just see the nice, pretty picture at the end. So if you work with clickstream data specifically, a lot of these tweets probably resonate with you. My favorite one is the one from Brittany that says, "How silly of me to assume the event ID is the unique ID of the event." I wish Brittany was here. I think she has tweets probably in almost every presentation. But a lot of these speak to me. I work a lot with our clickstream data at Drizzly, and a lot of things can go wrong. Maybe a property like this doesn't actually assume like what it should be. Things change over time. As your product, you're working with changes, so does your data. Maybe you're not involved in those decisions, so it just ends up happening without you knowing about it. Maybe the data types aren't what you expect. So many things can happen. And a lot of this is because we work in this world of implicit contracts. So what that means is you're meeting in a room with the engineering team or the PMs, you're coming up with a tracking plan. Maybe it all lives in a Jira ticket or a Google Doc, and that's that. So maybe it looks good at first because your engineer implements what's in the Jira ticket, but over time it can degrade and make things pretty hard. So let's look at some real-life examples. Maybe you're building this DBT model and the is sponsored value is always a Boolean. So you make this column here and it works, you test it in dev, like there's no problems. Maybe a couple months later you wake up to this error message. An empty string makes its way into the data. So you have to investigate, figure out what happened, where this is coming in. You reach out to the engineering team, to your PMs. And then they just file a bug ticket and it gets lost in the backlog. So you have to figure out a way to make this not break going forward and deal with all of the uncertainty that's coming through the data. Maybe you're like Drizzly and you have multiple platforms. We have a website, an iOS app, and an Android app. Ideally, an add to cart would look the same across platforms, but in this case, it does not. You can see column names are different, data types are different. You can see price on the web. Doesn't have a $, but it does on iOS. So there's things like that that happen, and you end up with these super long, complex case statements that just keep getting longer and longer and more complex over time, which makes it hard for other people to figure out what's going on and contribute to those models. This is my favorite one. You have an event label here. Sometimes it's scheduled, sometimes it's later, sometimes it's a misspelled scheduled. And this just this just happens when us as data people have to investigate our data and see all of these nuances that are happening and figure out ways to make it nice and clean so the people actually using this data downstream don't see all this mess going on in the background. So this talk is about JSON schema and data contracts, so let's define what some of those things are. So what is JSON? Here's an example of a JSON file. JSON stands for JavaScript Object Notation, but it's really just like a way to transport data. And it's really nice because it's human readable. You can look at this, you can easily see the fields, what the data is, and it's really used pretty widely. We use JSON a lot at Drizzly. We have a lot of data that comes in JSON format. It was really hard to use a while ago. Data warehouses didn't really treat it as a real data type, but in the more modern cloud data warehouses, it's become super, super easy to use JSON and transform it. This is actually the manifest JSON from DBT. So if you're using DBT, which probably a lot of you are, if you're running DBT, this is always populated with your most recent DBT metadata. So who uses JSON? Probably most people in this room use it. If you want to throw in the chat in Slack, if you're using JSON, maybe tell us what you're using it for. So that begs the question, what is JSON schema? This is a file that looks very similar to the first one we just looked at. JSON schema is really just a way to describe the JSON data. So here we can define the properties we have, the data types, specific values that should be in those fields. So it's a really nice way to tell whatever systems we're working with what that JSON should look like. Again, this is the JSON schema for that manifest file we were just looking at. So DBT knows the power of JSON schema and is using it in a bunch of their systems. So who uses JSON schema? Well, DBT, as we just saw. If you're using really any of the DBT artifacts, those are all JSON and they're all governed by JSON schema. So yeah, if you're using run results, manifest, those are all defined in JSON and have a JSON schema. There's actually a DBT YAML validator that uses JSON schema. If you go to the DBT Labs GitHub repo, if you're a DBT Cloud customer, anything you do in DBT Cloud is being tracked through Snowplow, and all of those event JSON schemas are being validated through Snowplow as well. And a bunch of other companies. You can think about Singer for data streams, Airbyte for all the different schemas that go through there, Stitch for all the different APIs they connect to, and Zapier for all the different integrations that they support. So there's a lot of talk about data contracts, so let's define actually what a contract is. The really high-level definition is that it's an agreement between parties creating mutual obligations, but let's take it a step further. And we can say that a contract is an agreement that enables people, businesses, and society to come together and collaborate towards their specific desires and needs. So I'm going to pass it off to Jake. He's going to tell us why we should apply these concepts to data.
Awesome. Thanks, Emily. Before diving too far into the how, of applying these, let's look at the why. Why is this important? Why is it a thing that companies like Shopify, companies like Slack, companies like Zendesk, and the list goes on, Airbnb, Netflix, on and on and on. Not necessarily with JSON schema, but definitely schematized data first and foremost. So this is the data team. We're going to call the data team Will. And Will is super competent and has seen Redshift and Snowflake and Trino and all of these other systems come into fruition. Maybe has dabbled in RStudio, uses Jupyter, obviously, DBT. He saw a guy at a conference riding an inflatable duck and has dabbled in DuckDB, or follows Josh Wills on Twitter. He's really capable at this very specific set of tooling and domain. And this is the product team, and we're going to call the product team Chris. And Chris might have, cut his chops on .NET over a decade ago, has been working in the JVM, climbed out of that, and is working in React and TypeScript now. Very, very different set of tools. Still super capable. Still, solves problems actively with his, sweet spot of tooling. And if we zoom into their working relationship, this is what we see. The organization puts these two people together, says work together, and do X, whatever X may be. Get data from this, report on this other thing. And at the end of the day, Chris is speaking one language, Will is speaking a totally different one. And it's basically international business between Babel and Google Translate. So super friction filled, easy to get wires crossed, and not altogether successful. But if this was the end of the dynamic for our friend Will, it would be okay. They could go out for drinks, maybe learn to work together better, whatever it happens to be. But for our friend Will, this is actually the dynamic. So as a company grows, new business units are spun up. They need to report new things. And Chris has a very different tool set. Every single one of these Chris's has a very different tool set. And our friend Will has to keep up with all of this, right? So the friction only multiplies. Will turns into mostly retroactive, I'm trying to keep up. I'm trying to get data from wherever Chris just put it. Maybe it's Parquet and GCS over here. Maybe it's a TSV or just raw JSON in S3 over here. And he just has to keep up. And really, the only way this working relationship or working dynamic from an org perspective is sustainable is if we multiply Wills, according to however many Chris's there are. And we all know that's probably not going to happen. So, at the end of the day, pressure builds, the working relationship becomes more tenuous, and, it often doesn't end well, as the Academy Awards have perfectly illustrated. So, how do we fix this? Where do we go from here? What are steps that we can take to, improve this relationship? So first and foremost, we have to reduce friction. We have to improve collaboration somehow. Really typical kind of mechanism for attempting this is inject some PMs and PMs keep really detailed Google Docs or projects or whatever, and that's okay. But ultimately, if we can ultimately improve this with collaboration between people, but also machines and our systems and our processes, that's obviously the ideal way to do it. So coming back to schemas, schemas act as this really powerful intermediary in the relationship of both parties can contribute to this shared entity or this shared understanding, and they both benefit. It can't be one-sided benefit. You just simply cannot tell people to do stuff when only one side benefits, especially if that side is the side that's telling people to do stuff. So we have to get to a place where both sides benefit from the upfront work that it takes, which we'll dive into. And coming back to the previous slide of actual real life, when discussing the org, when the Chris's multiply, you actually get this increasingly powerful intermediary of what a business looks like, what are the entities, and what are the business oriented knowledge within that. So long before a dictionary ever became a thing, a concept and a word to describe that concept must first exist. So similarly with data, like the concept is the payload. The thing that represents the concept is this, declarative thing, and it enables a lot of downstream stuff. So the second one, largely, is just reducing toil across the board, so that we as teams can refocus our time and energies on not doing the same thing over here in YAML and the same thing over here in protocol buffer and the same thing over here in JSON schema, and then this is a Go struct and this is a TypeScript interface, and it's just a lot of toil if that's all manual. So as much as we can reduce that, the better, right? So, ooh, my notes didn't show up. That's okay. So how is toil reduced here? As somebody that doesn't like to do the same thing over and over, how do we offload this to computers? And JSON schema is one way to do it. It's a pretty nice way. It enables a lot of this stuff to be chained downstream, right? So tools that we can share links to later allow for fully fledged SDKs to be generated from that shared intermediary between those teams. So ripping out TypeScript interfaces, again, packaging it up into normal packages for software engineers, whether that be TypeScript, whether that be Java or Go or whatever it happens to be, is a really nice thing to do automatically. So people are going to do the work anyway, and schematizing up front allows for a constant of 1 instead of a constant of the number of different programming languages or systems that need to integrate with each other. So that's what CS 101. So data discovery, it's really hard to pull metadata. It's doable, but it's just hard. But proactively declaring it and then pushing it out for data discovery systems, when schemas are drafted, they also can be annotated. What are the properties with PII? Who owns this schema? What is the high-level functionality of it? A description so that humans can read. Those are all really, really powerful things for creating sustainable data systems. And push is really nice. From my perspective, I've mostly worked on the platform and data engineer side of things. I started my career in basically BI, and from my world, a lot can be automated, right? Taking a schema and creating a corresponding Kafka topic or Kinesis stream, or populating a NAT subject or RabbitMQ or whatever is super doable. A schema and a namespace are a thing, and it makes for less friction there. But I don't think the story ends there, because you can take the schema with its corresponding data types, its descriptions, and rip out snowflake tables with comments that flow from the source all the way through to the destination. DBT sources and all of the analytics engineers, those are YAML. They're pretty easy to generate from JSON schema or whatever structured representation of the data that flows. So just stitching these things together. And then coming back to statistics, observing data in transit is this really, really powerful, important thing that you should do. And a schema and its corresponding namespace allows for those, or version or whatever, allows for event level volumes, or dead man's alerting, yes, no, data is flowing, to be defined at the schema level. So it becomes sure, we're doing monitoring and alerting on our infrastructure and our physical hardware, but also what's flowing through that hardware. And finally, in terms of improving this dynamic, data quality is always a subject of conversation. Being able to describe things up front and validate them later in data systems, or not let them ever be emitted because the compiler said no, you can't do that, is a really nice step for not letting data get out the door. But then downstream, there's a lot more to be done. or that can be done, I guess, with those qualities, so, or with respect to quality. And then from an accessibility standpoint, I once thought that like if everybody just used the same system to access data, if we just use Snowflake for everything, then life will be good. But the reality is like very much like programming languages and very much like personal preferences, and like you want diversity of tool sets and diversity of like opinions and capabilities. Access of data is very similar. Like the SREs like expect these systems, you know, to be in place and the data to be represented there. Grafana, you know, Victoria metrics, whatever happens to be. You know, product teams expect to be able to, you know, ship data or access data via an SDK, which can be generated again from JSON schema. You know, data engineering humans, they care a lot about the transport, which product engineers sometimes do, but like they probably shouldn't. Or, you know, if they like it, sure, but, you know, that abstraction is really typical of just like our insight ends when it gets fired and received somewhere. So similar, like, you know, data engineers care a lot about the storage systems. They care a lot about how data is structured in data warehouses, or, you know, file systems or whatever it happens to be. And then, you know, the overlap with DBT starts there between, you know, data engineers and analytics. So analytics care about getting it out of whatever storage system, and, you know, using DBT to do so. So looking at the time, are we like over? Am I 7 minutes over right now? Is that right? Anyway, I'll keep going. So yeah, JSON schema allows for a lot of automation throughout all of these systems. So the workflow here can be broken down. You know, there's a collaboration step, right? This thing has to be generated. It has to be written somehow. But it's not only collaboration between people. Like sometimes, you know, it won't be the product engineer and the data engineer. Like data engineering or a data engineer implementing instrumentation for their own purposes is like super common. But it's also collaboration between like the humans that kick off the process and all of the systems downstream, right? So throw a schema into a registry and just like have a computer do a bunch of stuff for you. Build your SDKs, again, broker your schemas into data discovery tooling, generate DBT sources, you know, the list goes on. Provision infrastructure, whatever it happens to be. The second step of, you know, this super high level workflow is just instrument your stuff, right? Put new tracking in the code base, use an SDK to, you know, drastically improve that process. And in doing so, what you get is like the normal software engineering workflow ever, right? So implement it, run it through CI, and deploy the tracking. And then again, from kind of the pipelining and data engineering or platform perspective, like do a bunch of stuff with it, make it discoverable, make it observable, validate it and bifurcate it if you want. Give people statistics that they can self-service, and then finally, you know, marking up schemas is this really powerful component of doing data governance. PII, redact things, obfuscate things, tokenize things, whatever it happens to be. So, in closing, like this workflow is very not new. It's not revolutionary by any means. However, it definitely can be applied in new domains and across new boundaries, and that's really fun. Schema-centric data platforms, also not new. Like there are dozens of articles about really capable, you know, very large companies that have all centered around a very similar concept. But what is new is people are getting way better at doing data stuff in general, right? So like tools like DBT, tools like Snowflake, you know, these tools are like drastically raising the floor. And what that means is like the big company problems are actively being seen by more and more companies because, you know, this kind of like maturity curve is being climbed. So that's all I got. Thanks for coming, and yeah.